Precision etiquette.
What type of expansion valve regulates its flow based from section line superheat? ABCD hand expansion TXV automatic none of the above.
B. TXV.
A thermal expansion valve has a liquid-filled bulb that is connected to a power head via a capillary tube. The bulb is connected to the outlet of the evaporator and will modulate the flow of refrigerant based on the evaporator outlet temperature.
Systems where the pressure drop across the evaporator is excessive would typically use an ABCD externally equalized TXV, internally equalized TXV, pressure limiting TXV, self-equalizing TXV.
Externally equalized TXV.
In systems that employ large evaporators, it may be necessary to use an externally equalized expansion valve. This type of valve has a separate pressure tap that is connected to the outlet of the evaporator. This design aids in controlling evaporator superheat more precisely in such applications.
On a system equipped with a TXV, when the load on an evaporator decreases, ABCD, the TXV decreases the flow of refrigerant, the TXV increases the flow of refrigerant, the TXV will maintain the flow of refrigerant, the TXV decreases the pressure across the evaporator.
A. The TXV decreases the flow of refrigerant.
As the load on an evaporator decreases, the saturation point in the evaporator will move toward the outlet of the evaporator. This causes the temperature at the sensing bulb to decrease and the pressure within the power head to decrease, thus throttling back the flow of refrigerant through the expansion device.
When referring to a power head on an expansion device, the bulb is on an automatic expansion valve attached to one end of a capillary tube. At the inlet of the expansion valve, normally charged with a fluid similar to that of the system, ABCD refrigerant.
D. Normally charged with a fluid similar to that of the system refrigerant.
The power head circuit of an expansion valve is typically charged with a refrigerant that is similar to that of the refrigerant that is charged in the system.
By subtracting the low side evaporator outlet temperature from the low side saturation temperature, the technician would be calculating A. Compressor superheat, B. Evaporator superheat, C. Heat of compression, D. Loss effect.
B. Evaporator superheat.
The only way to determine whether liquid refrigerant is not leaving the evaporator is to calculate evaporator superheat. Through this calculation, the technician can determine if the saturation point on the low side is beyond that of the evaporator outlet.
On a typically evaporator employing a TXV, the liquid refrigerant should be completely boiled to a vapor, A. near the evaporator outlet, B. approximately halfway through the evaporator, C. near the evaporator inlet, D. between the compressor and the evaporator.
A. Near the evaporator outlet.
To maintain the highest evaporator efficiency, the saturation point in the evaporator should be maintained near the evaporator outlet, but not beyond.
What type of TXV would be best for an application that was exposed to fluctuating ambient temperatures? A. Balanced port TXVs, B. Internally equalized TXV, C. Pressure limiting TXV, D. Self-equalizing TXV.
A. Balanced port TXVs.
The balanced port expansion valve is the best choice in applications where fluctuating ambient temperatures occur or floating head pressure is employed.
53. Pressure limiting TVs are generally applied on systems when A. the compressor will operate at low temperatures, B. it is necessary to shut off the condenser fan during a hot pull-down, C. there are constant evaporator loads, D. it is necessary to shut off the refrigerant flow to the evaporator when the suction pressure reaches a predetermined pressure.
D. It is necessary to shut off the refrigerant flow to the evaporator when the suction pressure reaches a predetermined pressure. URCM page.
Pressure limiting TVs limit the suction pressure so it does not cause the compressor to overheat during a hot pull-down situations.